Starting from the beginning, what is a Lightburn image mode? When you import a file into Lightburn that's not a vector format, the layer that gets assigned will show up as image rather than line or fill. 95% of the time this is used when engraving photographs. However, if you want to import a non-vectorized cartoon or digital graphic, it will display as image as well. To access the image mode, you double-click on the layer for your photo and you'll see a little drop-down menu about 3/4 of the way down the screen. Here's a list of the 10 image mode options that Lightburn utilizes. The first 9 process your image more or less the same way. The 10th option, Grayscale, operates by a completely different process. To understand the difference between the first 9 options and Grayscale mode, we need to do a little deep dive into how images work in the world of laser engraving. The first 9 on that list work by using an algorithm to convert your source image to a true 1-bit black and white representation by a process called dithering. To better explain this process, let's look at a regular color photo. Any color photo will do. Now, the first thing you notice when you import your color photo into Lightburn is it shows up with no color as a grayscale image. Notice how I said it's a grayscale image and not a black and white image. There is a difference, and in this case, when discussing image processing for lasers, it does actually matter. In extremely simplistic terms, a grayscale image actually contains gray pixels in varying intensity that makes up what the image is about. You can see this if we zoom all the way in on that photo we just imported. Very easy to see the gray pixels. Some are light, some are dark, but most are somewhere in the middle. A true black and white image will only contain, you guessed it, black and white pixels, no gray pixels at all. The only gray or shading that you see in a dithered image is the result of an optical illusion because there is no gray in the actual image. Last point on this, and arguably the most important. When the laser is running your dithered image, it's only taking into account the number you set for max power. Okay, let's pretend this is a zoomed in representation of our dithered image. You have the black pixels, you have the white pixels, and we have the power for our engraving set to 50%. And let's just pretend that our laser is scanning from right to left for right now. When your laser comes across a black pixel, it's going to fire at the max power, which is 50%. Comes across another black pixel, 50%. Comes across a white pixel, 0, it doesn't fire. Comes across black pixel, 50%. Comes across a white pixel, 0. Comes across black pixel, 50%. And comes across another black pixel, 50%. Very simple. Okay, with that out of the way, let's talk about what we all came here for today, and that is grayscale mode. We import the same color photo we used in the previous example. As expected, Lightburn disregards the color, and we're left with a grayscale image to start. Open the layer settings and switch the image mode to grayscale. At the bottom, you see a sample swatch and a little note of text that reads, "With a CO2 laser, this is variable depth 3D, not shading. With a diode laser, this can give great shading, but it's harder to use than dithering." I will clarify both of those points in the next section. Okay, so where to start? Probably the most important difference between this mode and the others is Lightburn does not dither your image before processing it. It leaves it as a grayscale image. The second most important difference between this mode and the others is Lightburn actually scales your laser power between the max power and min power settings depending on the shade of gray it encounters when processing the image. In the darker areas, it will fire closer to the max power, and in the lighter areas, it will fire closer to the min power. This is where it's going to get a little bit technical, but I'll try to make it as easy as possible to follow. From there, Lightburn is going to take the 2 numbers you set, your max and your min, and scale the power for all the steps in between. Here's an incredibly helpful graph I found on the Lightburn support forums that illustrates this point perfectly. You can see in the left column an example of 100% max to 0% min grayscale. There was a lot of space between 100 and 0, so you get a wide range of darks, midtones, and lights. The middle column has a much tighter power range, 50 to 20, therefore a much smaller range of tones. The right column shows a more middle-of-the-road power scale. Now you might be thinking, okay, that's cool, but how do I know how that scale applies to the tones in my image? And that's an excellent question. It's also the part of grayscale mode where a lot of people are peddling some incorrect information. It would be very rational to think that when Lightburn is processing your grayscale image, it's going to set the darkest pixels it sees to your max power and the lightest pixels to your min power. And I wish we lived in that world, but sadly we do not. Lightburn will always peg your max power to pure black and your min power to pure white. The problem with that is your image might not have any pure black or pure white in it at all. Alright, back for another quick whiteboard demo, this time with grayscale mode. Before, all we had was black and white pixels. Now we have black pixels, white pixels, and a couple shades of gray. This time the laser is firing from left to right. It comes across a pure black pixel. It's going to fire at max power 50%. Comes across a pure white pixel. It's going to fire at our min power. This time it's 10%. Next, it comes across a middle gray pixel. Let's say Lightburn assigns that to, I don't know, we'll say 30%. Next, it comes to a pure black pixel, so it fires at max power, 50%. White pixel, back to our min, 10%. Darker gray pixel, let's say it puts that at 45%. Another lighter gray pixel, let's say 20%. And then again, pure black, max power, 50%. And you can see, unlike how the dithered image operates, this one modulates the power. So it starts up real high, max power, drops down to the min, comes up about mid-range, goes back up to the top, goes back down to the bottom, goes back up close to the top, another lower mid-range, and then back up to the top. The power modulates instead of being just an on or off trigger. And if that wasn't confusing enough for you, you also have to consider the material you're working with. The majority of materials we like to engrave on every day, like wood, acrylic, or slate, aren't going to give you a beautiful wide range of tones. You can see this by looking at your material test results. Some materials like glass or acrylic don't have any midtones at all. It's either engraved or it's not. So trying to use grayscale mode on a material like that is wasting your time. The only way you're going to get a shading effect on something like glass or acrylic is by using a dithered image. So with all that being said, when would you actually want to use grayscale mode? Because it sounds like a massive pain in the butt. Well, let's go back to that little note that Lightburn put at the bottom of the window. With the CO2 laser, this is variable depth, 3D, not shading. With a diode laser, this can give great shading, but it's harder to use than dithering. This is a very succinct way of saying that depending on your laser type, CO2 versus diode, you will use grayscale mode to produce two totally different outcomes. Here's a quick look at two grayscale mode examples I did on some anodized aluminum business cards. There's just such a highly realistic level of shading that you get using grayscale mode that's really hard to duplicate using a dithered image. Like the subtle shading on her cheeks and on her arms, even that pure gray space between the two girls in the middle there, that's just really hard to do with dithering. Here's another example. I did one of these on my fiber laser, and this one I also did on my Xtool D1 Pro 20 watt using the grayscale mode. And again, it's just the high level of shading detail. It looks like this could have been just printed on this card instead of laser engraved. If you have a CO2 laser, you'll be using grayscale mode to create physical 3D depth. However, to achieve that effect, you need a very specific type of grayscale design. These types of grayscale designs are often similar looking to depth maps, which are more common in 3D printing and the CNC world. Here's a cool example from the Lightburn forums. The material most commonly used for this type of work on CO2 lasers is going to be wood. It's thick, it's soft, and easy to engrave, therefore it's perfect for grayscale mode. Well, now you might be thinking, why is there a distinction between how this mode is used on a CO2 laser versus a diode laser? Mainly that comes down to just pure laser power. A 10 watt diode laser doesn't really have enough power to engrave that deeply into a piece of wood to create that desired 3D effect. However, it would be interesting to try it out with some of the newer 40 watt laser modules that exist now. I'm sure some of these guidelines were created back when diode lasers were basically toys. On the flip side, a 65 or 100 watt CO2 laser just possesses far too much power to do delicate photographic shading on something like anodized aluminum. Not to mention the beam size is much larger, therefore you get much less detail. The final caveat I will mention is not all laser controllers support the use of this type of power modulation. I tried finding a list of those that do and those that don't, but came up empty-handed. It seems like the most popular ones do support it though. In conclusion, 99% of the time I suggest just using a dithered image for engraving. It's by far the most common way of doing it and much easier to troubleshoot. However, if you have a CO2 laser and want to try getting some 3D depth, grayscale mode is most certainly for you. If you have any specific questions on grayscale mode, you can add them in the comments section below and I'll try to help out to the best of my ability. I have been using this mode for a while now, so I think I could at least point you in the right direction. Thanks for watching.